Yeah, thanks, Daniel, for the introduction. I don't need to say anything on this slide then. And moving to the next one, you already talked about me. So yeah, I'm an assistant professor at Boise State University, and I graduated my PhD from University of Alabama, and I'm one of the BSSW fellow. I received the award in 2020, and I also have a little bit of work experience at NCSA and Los Alamos National Lab as summer interns. So what is research software? So this is RSC workshop. I don't need to talk about this. So software quality in research software is very important because researchers draw insights and make critical decisions based upon the results obtained from research software. So therefore, the correctness of the design and implementation of this software is of utmost importance. And if the software is of low quality, then the results are less trustworthy and prone to failure in mission critical situations. And low quality software may also lead to incorrect research conclusions. But it is challenging to make the research software error-free because of the complexity of the underlying science, relatively unknown results from the scientific algorithms, and the constantly growing stream of data. So we have also observed that the researchers often place less importance on traditional views of software quality than on other scientific goals. So regarding this impact, so the purpose of this paper was to understand the current state of the art of testing, like how other people are testing the software. So it started a while ago in 2019, before the pandemic. I was in an internship at Los Alamos National Laboratory to develop a testing framework for a research software. So I had some really interesting challenges. So I thought it would be interesting to know how others are testing their research software. So we conducted an online survey. So at first we piloted the survey directly with some experienced research software developers and adjusted the wording according to their suggestions and just to make everything is clearly understandable. So if you're curious, where did we send the survey? We sent the survey to the Slack channels we have and any mailing list of research software developers. And also we sent the survey to BSSW newsletter, IDS, ECP, productivity mailing list. So yeah, at the end of the survey, we were able to gather 120 complete responses to include in this survey. And yeah, so I'll be talking about a little bit of demographics. So yeah, there are a bunch of other information in the paper itself. It is published like a month ago. And then you have all the details out there. Just I am here to introduce you the topics out there so that it's beneficial for you to read the paper. For the demographic information, I'll be pretty quick just to let you know what kind of respondents we had during the survey. So this figure shows that respondents were skewed more toward technical roles like developers and architecture than toward non-technical roles. And you know, so we can see that most of the participants had more than a year of experience working in research software, and just under 1/3 had more than 5 years of experience. Close it. And only a small number had less than 1 year of experience. And the project history, the projects represented by the respondents were overwhelmingly in the released state. So this result is important because projects at this stage should have already established testing programs that they deem useful. So we can also see in this figure that most of the respondents worked on smaller teams in terms of the number of developers, that is 1 to 5. So what level of knowledge do research software developers have on software testing? Is there a message for me? Okay, no, sorry. So we asked the respondents in the survey question that how confident are you on your knowledge of software testing? So most of the respondents mentions at least average level of confidence of knowledge of, And then more than 1/3 respondent think that their confidence level is in the range of high and very high. So while we asked their understanding of the testing concepts used in their project, so more than half of the respondents mentioned high or very high level of understanding. Only a few participants mentioned low or very low. And in terms of the understanding of the testing concepts needed, The responses are overwhelmingly in the range of average and high. So now the question is, how do research software developers perform testing? So we asked the respondents about their goals of testing, and the maximum number of participants mentioned level 4, which means testing is a mental discipline that helps all researchers develop higher quality software. And then the second highest number of participants indicated level 1, which means the purpose of testing is to show correctness. And then the next highest level is level 3, which means the purpose of testing is not to prove anything, but to reduce the risk of using the software. Just so you know, level 0 means there is no difference between testing and debugging, and level 2 means the purpose of testing is to show that the software does not work. So this comes from a textbook of software engineering or software testing in particular. Then we asked the respondents about their usage of testing methods. So system testing is the most popular one in research software development. And then a lot of the respondents mentioned unit and integration testing as well. So almost all of the respondents mentioned testing was useful, like always or most of the time. Only a few participants mentioned sometimes or rarely. And then, so why is testing research software difficult? So some of the interesting results are coming up soon. So we asked the respondents that how complex is their testing process. So half of the respondents indicated at least moderately complex to test their project. And 1/3 of the participants mentioned slightly complex. Then we asked them to explain any challenges or barriers they face to test their project. So the most common answer to this question was test case design, because application cases are usually too big or expensive to test. So breaking them down for meaningful system test is a challenge. And then the second most common answer was lack of resources, which means lack of money, lack of people, and lack of time. And then the next thing is external dependencies, which means research software often depend on external hardware, software, compiler, etc. that makes testing difficult. And because research software developers are not trained software engineers sometimes, so there is always a lack of knowledge. And so here we are talking about research software developers in general. So most of them may not identify them as an RSE. So we expect the RSEs to have a little more interest or knowledge on software engineering concepts. And many respondents found their testing process is very low, but they always have some sort of deadline to finish the task. And there is a cultural difference between the researchers and software engineering community. And one unique challenge research software developers poses regarding testing is comparing with the reality. That means testing ocean model or climate control or nuclear weapons or something like this. And because of the lack of proper knowledge and resources, they may usually have a poor code base, which is hard to test. And many of their code is legacy code. Also, there were a few other challenges. So in this case, we referred the testing methods currently used in commercial and IT software development. So these methods include unit integration, system acceptance, and module testing. So gaining a better understanding of how these methods apply to the testing of research software will help research software developers have more confidence in the methods they can use and reduce the need to discover this information on their own. So we begin with a survey question about the frequency with which respondents use commercial IT testing methods as a team. So as this figure shows, most teams apply these methods at least sometimes. And there are a few teams that apply commercial IT tests rarely or never. And similar to the case when we asked the respondents about the use of commercial IT testing methods personally. So as we can see in this figure, most individuals apply these methods at least sometimes. And there are a few individuals that apply commercial IT tests rarely or never. And beyond whether the respondents use the commercial IT testing methods, we ask the level of value they see personally in using these methods. And so the distribution of the results in this figure shows that the respondents generally saw value in using such methods. So with more than half answering high and very high. And to gain an understanding into where the commercial IT methods cause problems, we asked the respondents to explain any challenges they face in an open-ended manner. So our qualitative analysis of these results identified 9 high-level categories of challenges shows in the figure. So I discussed some of these challenges in detail in the response to the next coming questions. So I'll highlight a subset here. So overwhelmingly, the most common challenge respondents reported was the methods were not useful. So this challenge arises because research software is typically not production software, and some commercial tools do not account for issues with numerical tolerances and things like that. And it is difficult to adapt commercial IT testing methods in the development of scientific software because of numerical errors and often not knowing the expected output. And similar to the overall difficulties with testing research software, the second most common challenge is to using commercial IT testing method is lack of resources. So one respondent explained the challenges as lack of expertise and schedule demands, or probably lack of R&D or software development oriented tools and things like that. The third most common challenge response is the mindset of the research software developers. So the problem is developers often feel like any time is spent on developing code for the core software is not real work. So thus the time is spent on writing tests is less enjoyable. And in addition, the problem is culture. That means convincing people that it is beneficial, necessary, and worth their time and not insulting to their work. And there are also challenges with mindset that originates external to the team, such as funding agencies are generally not aware of their importance, and effort is spent on testing is spent on writing, publishing or papers and things like that. So finally, there is a lack of familiarity with the ensemble of testing patterns and goals available. And there is a lack of knowledge, need for infrastructure support, expensive or difficult to use, and runtime restrictions, or that make research software difficult to adopt commercial and IT testing methods. So in addition to the challenges with adopting commercial IT methods, there are cases where those methods are just not applicable. So we asked the respondents to explain any challenges that could not be made by the commercial IT testing methods. The qualitative analysis produced 5 high-level challenges. The most common challenge is by the range of large margin was the methods that do not meet the specific need of research software. So these specific needs include visualization, image processing, analysis, like fluid flow simulation, simulations where there is no analytic solution or known correct answer, that is no oracle. So unique challenge of research software is that validation requires domain expertise, which is sometimes difficult to express in commercial methods. And another situation that is common in research software is whether the results are meaningful. So as I have a few minutes left. Okay. So the respondent also mentioned lack of expertise, slow to execute the test, continuous integration issues and benchmarks, and some other challenges that could not be made by the commercial IT testing methods. And finally, the improvements the research software developers thinks they need to bring in. So the respondents mentioned that there is a need for training, such as education, examples, templates, so that they can use proper testing techniques. And they also mentioned they need more types of tests and infrastructure support that will cover specific needs of research software. And another important aspect is acknowledgement for their time and effort spent on testing. Respondents also mentioned to create a culture of testing in the research software developers community that will help improve code quality, continuous integration, and moreover, making the testing process simpler and enough resources can potentially improve the testing process. to wrap up, what I said is overall research software poses a clear goal of testing their project, but the complexity associated with the process need further attention to make a culture of testing in the research software community, and providing proper training and resources can improve the process in research software development. So in 1 minute, so I got a question. I had a few recommendations, so I can take the question. Okay, so please go ahead.
Hi, my name is Chris. I've been a software engineer and tester specifically for 20 years. What about two short questions? And if this gets in the way, then just skip and move along. But what do you mean by commercial testing methods as opposed to other? And the second,
so
did you inquire about the possibility of just seeking engineering support?
Yeah, we have not specifically asked for engineering support. And for the commercial IT testing methods, we use the conventional testing techniques like unit integration, system, module testing, acceptance testing, all that. For example, acceptance testing is not pretty much used in research software because acceptance testing is mostly for users to accept the GUI applications and all that.
Thank you.
Okay. Yeah, next question. Play.
Yes, I was wondering how, if like scientific journals could play a role by requiring testing or evidence of testing upon like submission of a manuscript, or if reviewers could enforce the requirement of testing.
Yeah, that would be wonderful. So oftentimes there are venues like software engineering journals and conference for testing in general, but because this term research software engineering and development is pretty new, I don't see any specific venue we have, particularly for testing research software, but that would be wonderful to have. And yeah, Dan Katz added to JAWS and other software journals ask for testing. So would you, can I ask Dan, so would you accept testing in research software as a topic? For example, I submitted a paper on software engineering conference and they say it's a good topic, but we don't have enough audience for this. So the paper is well written, but we cannot accept it. So things happen. Read.
Oh, do you want to take my question, or do you want to finish your recommendations and then take my question?
I can take your question.
Okay, if you're certain. So I do have a question for you just in general about this. So on the RSE kind of angle, right? So we are seeing a trend towards more research software engineers on research software projects, right? Do you think this will help with the testing complexity problem, or is it that the tests are complex because the domain is complex, and to what extent could RSEs actually help with that? Like, what's the, I want to know.
So yeah, my study findings says that we need some specific features on the existing tools. For example, handling for numerical tolerances, or more on the floating point issues and all that. Also, the domain knowledge. Sometimes we are testing the science behind it on the algorithms. So the current testing tools can only provide the input and output you are going to test, yes or no, or some kind of binary results. But we need some sort of granular level or gray scale of results, like for example, machine learning results of F1 score and something like that, so that it can compile with the domain knowledge under it. And then I just wanted to say something. I got distracted in the chat message, sorry. And yeah, on the domain knowledge thing is the domain expertise we need. That should be maybe some sort of automation using machine learning incorporated with the testing tools, so that it can at least give us some sort of simulations or grayscale results.
Gotcha.
Do I have questions, or but I don't know what is happening in the chat. Okay. So if there is no more question, can I go and finish my slides?
Go ahead, Nasir. I'll organize questions for the end.
Okay, yeah. So some of the general recommendations I had, like very in general recommendations, to provide enough training on research, software testing to all kinds of research software developers, ranging from graduate students to experienced researchers. and then incorporate more tests that can solve the specific needs of the research software, providing infrastructure support, for example, a public service of testing, like including many tiers, pricing structure for machine time, and sophisticated test dashboard. And and then provide automation for setting test and analysis of the results, like improve continuous integration system to facilitate a better way of testing, especially the incoming test during downtime. And then make a culture of testing in the team and encourage others by sharing and benefits from the experience of testing, and improve the quality of testing so that the developers can write tests easily. And then improve the quality, So I think, and some other ones provide proper acknowledgement of developers for contributions in testing, and make the testing process simpler so that it's easy to adopt in the project, and provide enough resources to developers so that they can utilize the resources to develop test suites. And more questions and time in terms of, so Dan Cantor has a question.
So thanks. That was a great talk. I have one question. I don't know if I missed the very beginning of it, honestly, but did you mention sort of existing infrastructure on GitHub? Because for us, that's the sort of default place to go for testing infrastructure, and probably true for a lot of projects.
No, I did not mention anything on that.
I
So
think
are
that
you talking about
infrastructure,
CI systems?
GitHub
built on
Actions,
GitHub
in particular,
Actions,
but other ones that maybe, there's some other alternatives that people use a lot as well.
So we didn't specifically look at this on the responses we get. But that's something very interesting. Especially GitHub Actions are nowadays very popular in the industry, and I think.
Yeah, I find I don't know how other people are experiencing that. That solves some of the problems, but I think with, there's always specialized things you need to do, or things that take too much resources that it's not going to be very practical for.
Yeah, I agree. So I can take more questions. Here is my email address. Boise State gave me a long email address, but very easy to remember. And please feel free to reach out to me. And so it was just a step one to gather the current state of the art, and then a lot of exciting research is happening in my research lab. So if you have any questions, so feel free to reach out to me or Jeff Carver. So we have 3 participants raised hand. Okay. So if we have time, we can go on and on. So Daniel,
let's go with Reed first, because I'm not sure who had the hand raised first, but go ahead, Reed.
Oh, sorry, my hand was still raised. I'd already asked my question.
So I realized that.
Yeah, I had the same problem.
Oh, okay. Well, I had one question from your recommendations. You were mentioning sharing people's success stories with testing and such. I'm curious, like both, I guess, 2 questions in one maybe. Within the survey, if there was a collection of success stories and say outcomes of, like, say, well-integrated testing within research software workflows, and how that correlates to, say, improved outcomes. And then through that recommendation you gave, like, which are there specific success stories that you would specifically share with the community here to encourage adoption of, like, testing within their workflows?
So we are working on a follow-up survey on this. So I hope to have some results from that survey on the success stories. I think that would be very wonderful addition to come to a community talk or a workshop to speak about. For now, I can tell about what I did on Los Alamos National Laboratory. So we had a non-deterministic software project that produced different results every time. So we were really trying to use any of the commerciality methods or conventional testing techniques to apply on it. But during the time frame we had, so finally we had to do any statistical testing. So that was kind of new in software testing, because you don't usually use a statistical test on that. For example, we used multinomial testing and then we hacked the molecular dynamics engine behind, and we build our own Markov chain molecular engine for that. So that's the science part of it. And then we were able to run multinomial test to get some yes, no, or binary results based on the p-values we received. So I would say that is a success story, and I had published a paper on that. So that's the title is Testing Research Software, a Case Study. So you may want to read it. So you may have similar, so many of you may have the similar scenarios where you cannot apply. And then on that paper, I described like which methods we wanted to use, for example, metamorphic testing and or runtime assertion, so things like that, but why we were not able to use that given the restrictions we had on the systems and all that, and why we had to hack the backend engine and then finally able to test the outputs and all that. So that is a success story. And I would love to know more of success stories too. David?
Thanks, Nasir. Yeah, I just wanted to ask, and you might have covered this and I just missed it. Are you thinking about maybe dividing things up into a researcher who has an analysis and wants to test that compared to a research software engineer who's testing a framework or a whole system? And I just asked because we just got a submission at PyOpenSci of this package. It's test-driven data analysis. And they're basically like trying to map this idea of test-driven development onto your like analysis pipeline. So I feel like some people are thinking about this, but I don't know how much thinking's been done about it.
Yeah, but I would say you gave me a very good suggestion for future work. Yeah, thank you for that. Yeah, definitely it would be interesting to know on this. Yeah. For now, I don't have anything analyzed like that, but that sounds very interesting.
Thanks. I'll look for the future work.
Mm-hmm.